Hi, I'm Jason from the Centre for Computing History. I'm here today with Ewan Wordsworth. Ewan is somebody that you might not know if you're a UK viewer of some of the stuff we've done before. We've obviously featured a lot of UK machines, but Ewan has been involved with the Microbee, very much the Australian version of the BBC Micro. So Ewan, welcome to the museum.
Thank you.
Tell us a little bit about your involvement with Microbee.
Well, I started at Microbee when I was fairly young. I was in my teens. I started off in sales, doing casual sales, just in the local store. We had a store in Melbourne, and worked in sales for probably about 3 months, and then moved into the service department because I'd always had a liking for electronics and showed aptitude for it. So just moved into the service department and started servicing machines. We had a lot of machines out in schools at the time, so it was a big job to take care of all the machines that were being treated by kids every day. And
I know what you're saying.
yes, just looked after the whole, basically the state's, Victorian state school servicing. Obviously personal users as well would come in and have their Microbees serviced or upgraded. We did a lot of upgrades. The design of the machine was such that you could swap bits in and out and get a better machine out of it. So it was a very busy time.
Right. So these are individuals that had their Microbee, that they'd bring them into you. You could upgrade them or whatever.
Yes,
Yeah.
yes, we offered an upgrade path. The original machines came out were just ROM based, so they didn't have discs attached or disk drives attached. They had cassette based program loading, and so people would, as they progressed through their computing needs, they would upgrade it to a disk based machine. So we'd swap one of the boards out and add a disk drive to it, and so you had full CPM on that.
So the Microbee is actually capable of running CPM?
Yes, it is.
Right,
yes.
so it's a Z80 based machine.
Yes, it is.
So yeah, upgrading it to be able to run CPM, that was probably quite a thing for the time. I mean, there were quite a few CPM machines out there, but they were kind of more dedicated business machines, weren't they?
Yes.
To have a home computer that was running CPM was probably quite advanced.
Yes, it was. It was designed basically for use in schools, but it had wider applications as well as we have primary schools that the machines were used in a lot, but they started getting used in secondary machines, so secondary schools, so they needed better software, more flexibility as far as getting software goes and that sort of thing. So the disk machines became very necessary.
Yeah.
Wider use in the business community as well, and just for general home use, it was much easier to have a disk drive and CPM.
Yeah. Well, okay. So so where did this all start?
Well, Applied Technology was the original company that had the Microbee. They started off as a component supplier, like general electronic components. You go into a store and you buy components
Transistors and diodes and chips and stuff.
Make up whatever you wanted out of it, out of some of the magazines, popular electronics magazines at the time, that sort of thing. Then slowly went into supplying computer parts, CPUs, RAM, ROM, all that sort of stuff. And progressed from there to have single board computers or S100 based computer cards that were either pre-built or as a kit of parts that you would assemble and hopefully get working.
Hopefully.
Yes. The Microbee came about because there was a need for a cheap, easy to use computer for schools in Australia. And it originally came out as a kit form, so you would get a bag of bits and some printed circuit boards and all the bits and pieces that went together, and you would get a working computer out of it that was quite advanced for its time. At the same time, it was the same sort of machines of the era. It was the Apple II, the Tandy TRS-80, those sort of machines. The Microbee offered better graphics for a base model machine, It had higher resolution rather than like the Tandy's low resolution blocky graphics and that sort of thing. The Microbee had 512 by 256 pixel resolution, which at the time was very good.
Yeah, pretty good at the time. Yeah, it sounds nothing now, does it? But actually,
That's
yeah,
right.
going back then, that was pretty decent.
Yes.
Was it a colour machine or just black and white?
At the start, it was just monochrome. There was upgrades quickly as the demand for the kits became larger and larger. It actually became a fully manufactured product rather than just as a kit machine. And it got a different case, a better full ABS plastic molded case, whereas the original one in kit form was a metal base and a fiberglass top.
Right.
To go around the machine. But as things progressed and more demand came on, there was upgrades for the machine, both as you could apply them to your kit, but the machines were upgraded in their design to include higher characters across the screen.
Right.
So the original screen was 64 characters across by 16 down. But then it was upgraded so you could also have 80 by 24 characters.
Right.
And colour was added, the ability to add on disk controller and floppy disk drives to it. Later on it had a hard disk model as well. So it was a 10 megabyte hard disk that you could purchase for it.
I bet that was pricey.
Yes, it was. It was luxury at the time.
Yeah.
Absolute luxury, but
But you had a whole 10 megabytes. I mean,
yes.
you'd never fill that, would you?
No. You had to work hard to fill it up. It was good.
Okay, it sounds crazy to say, just a sign of the times, isn't it? That shows how much has changed since then. So the Microbee, like I said in the intro, it was very much sort of kind of the education machine in Australia. Is that fair to say?
Yes,
Yeah.
yes. It won the education contract in New South Wales to go into schools. That's how it started.
Right.
Against particularly the Apple II. There was other machines that were being supplied at the time into schools, but they were very low volume. Like I think they had the support for the TRS-80 Model 3 as well at that a little bit later on. But essentially the education market in Australia was the Apple II or the Microbee.
Right. How did it favour in terms of, or fair I should say, in terms of price with the Apple II?
It was a lot more cost competitive.
Yeah.
We got a lot of market acceptance because it was a cheaper alternative to the Apple II.
Right.
It was also an Australian machine, so it's supporting local companies and jobs and so on. So it did well.
Yeah. Fantastic. It's quite a similar story with the UK and the BBC Micro. Talking about the kits in the first place, then going on to machines that not that the BBC Micro was a kit, but Acorn made things like the Atom that was available as a kit. So it's similar kind of path through different processors. So your Z80 and 6502 for the Beep. So the Microbee done extremely well, and is the name that people would associate with schools' computers over there. So in terms of the going on from schools into the wider place, people were buying these as home computers as well.
Yes, absolutely.
Presumably because their kids were learning at school maybe and wanted something at home.
Yes.
So what was the range of software like for it? Was it mostly educational, or was there a lot of other stuff done for it?
There was a lot of games available for it. There was a lot of educational software. There was general business software available for it. Being CPM, you could use anything that was available for CPM. There was software that was written specifically for the Microbee by the company, but also outside software houses. It was well supported as far as software goes. Yeah.
Okay. So it's got three dimensions, hasn't it, really? Because of the business side of it as well. And again, another similarity. The BBC got used a lot in various different business things. Another company called Torch Computers took the BBC Micro, put it into a big metal case and sold it as a business machine with a ZNT second processor on it, so that could run CPM in the same way, but you could do it sort of natively.
Yes.
So we're lucky enough to have one in the collection, and we've got that one out. Would you just talk it through for us?
Sure. This one here that you've got in the collection is a ROM-based machine, so it had just cassette storage for loading and saving of programs, any data that you had in your software that you're working on. Perhaps you had a spreadsheet going that you wanted to look after your weekly expenses and so on. You would have the spreadsheet loaded in, but also the data you could save off to tape. And so it was a very, it was a good machine, but it still worked off cassette. One of the benefits of the cassette-based Microbees was that they had battery-backed memory in them, so that all the working storage that you had, if you typed in a program or you loaded one for tape or that sort of thing, if you turned the power off or the power went off accidentally or whatever, the contents of the memory would actually stay there. So whenever you turn the machine on again, up comes your program and your data's still there. So you don't actually have to load it off tape every time you start the machine up. If you're still working on what you were before, it was already there.
Now that's stunning.
Yes.
I don't know of another machine that does that, or did that. Yeah, so it uses just standard SRAM, static RAM. And you've got it backed up with a battery.
Yes.
I can't think of a single other machine that does that. And bearing in mind how much time you spend doing these, and then a cable just coming loose, or it's on the ZX81, it was the RAM pack that always wobbled.
Yes.
Although that corrupted memory, so that wouldn't have helped. But that's really useful.
Yes.
Why did nobody else think of that?
I don't know. A lot of companies in their designs were moving to dynamic RAM.
I was going to say DRAM was used a lot more, wasn't it?
Yes.
You can't just battery back that, can you?
No, you can't.
Yeah.
It's got to be refreshed all the time.
Yeah.
So,
and actually, SRAM was probably a bit more expensive though, as well, wasn't it?
It was,
so
but
it's a really nice feature,
but
but it was a little bit of a price, right? Okay.
Yes.
Yeah, great feature though. Sorry, go on, carry on.
Yes. So that was that machine. Basically, it had full keyboard. It was all completely housed in the one unit, like a lot of machines at the time. What else? It was commonly used for connecting to bulletin boards. There was a modem available for it, and there was telecommunication software that you could buy in a chip that could stick in there permanently and just issue a command through BASIC, and it'll fire up the menu for the communications package.
So that's interesting. There's another familiarity there. So you could actually put ROM-based software in it. You could buy chips and put it in.
Yes.
Another similarity with the BBC Micro.
I might actually, I'll take the top off this one.
Yeah, be interesting to see.
Just to give you an idea. It's a two-board design. So the main board underneath here has all of your CPU and I/O controller and your screen controller and the control of the keyboard, and then the top board here has all your memory. So there's your basic ROMs here, so basic in ROM. This one has a word processor built in, so once again another option that you could fit to the machine. That's the bank of static RAM there, and some blank ROM spaces. Normally the network or communications package would sit up in this location here. That's the backup battery that keeps the RAM all
That's very
safe.
cool. Very cool. So yeah, there's those 6116s, are they? The RAM chips, the 24.
Yes, those were
611. So yeah, that's
right. Later on, we used the 6264s just in this first slot.
Yeah.
Which were 8K devices instead of the 2K ones there. This one's got 32K of RAM.
Whole 32K of RAM. Wow. So
it's amazing what you could do in
absolutely.
even 8K.
Yeah, absolutely.
We had a model that came out with just 8K. It was called the Experimenter. So it was for basically someone that wanted to get a machine as cheap as they could, be able to hook things up to it, maybe off the parallel port here. You could control some relays or virtually anything. But it was an entry-level machine that you could just tack bits on and learn to program, and later on, if you wanted to, you could upgrade the memory in it.
Wow. So a bit of real-world computing in there as well, being able to link it up with external devices.
Yes, yes.
That's very, very cool.
Yes.
So the board that's underneath there, is that one big board that does all the keyboard as well? So the keyboard is on the main board, right?
Yes, it is. Yeah. Now we can pop the top off there. Hopefully I don't drop it. Come out. come out. There we go.
Right.
So on here we've got the screen controller. That's the CPU, the Z80 CPU.
Mm-hmm.
Over in this slot, which is missing at the moment, it's the I/O controller, which controlled the parallel port and serial port,
Mm-hmm.
and it also hooked up to the cassette interface. It was a bit banged cassette interface,
Yep.
and the speaker
Right.
for sounds.
Mm-hmm.
So it's not a very complex machine as far as sounds go.
Yeah,
So the other machines had sound chips in them
Yeah.
that did 3 voices. This was just a single bit
Mm-hmm.
that was toggled on and off at a particular rate
Yep.
to make a beep.
To get your sound out of it, right?
Yes.
Okay. Cool.
Yep.
Good stuff. So,
Right.
how much did it sell for in Australia at the time?
Well, the original kit came out for $399.
Right.
That was in 82.
Yeah.
Trying to count the years there. Yes, so it came out in February of 82.
Uh-huh.
It was actually launched in a magazine called Your Computer
All right.
in Australia,
Mhm.
and it had a 32-page lift-out section all about the kit, how
Wow.
to assemble it,
Uh-huh.
and some basic programming tips, some programs you could type in once you assembled the machine, that sort of thing. So that went very well.
Ah, fantastic. That's quite a splash to have a 32-page pull-out in a magazine.
Yes.
Yeah. Cool. So you mentioned some of the magazines that were out in Australia at the time, and was it Popular Electronics? Did you say?
No, there was there was a number of magazines. I call them Popular Electronics.
Okay,
magazines
we had
of the
Popular
time.
Electronics. That was a magazine over here.
Right. So there was magazines. Your Computer is one I mentioned that
Okay.
the kit was launched in.
Yeah.
That was just a monthly magazine that covered all of the home computers at the time, essentially, and news about any upcoming models and that sort of thing. There was columns each month for all the different common computer types like Apple II. Microbee had one after a little while. The TRS-80 had a column, and it was just about upcoming machines that are being launched and that sort of thing. It was a very good magazine. Then there was the electronics magazines as well. Electronics Today International there was an Australian version. I know there was one
Yeah, I
here
had
in
that
the
over
UK.
here as well. I never really considered the international part of it. I just thought that was, but
Yes.
obviously it's clearly over in Australia as well.
Yes.
Different adverts though, I would imagine.
Yes, there was. There was Electronics Australia as well. Both of those featured kits for the Microbee, or for lots of different computers, but Microbee was very good for supporting people that wanted to tack things on and play with the electronics inside the machine, that sort of thing. So people were enthusiastic about the machine in that way, so there was a lot of projects developed for it. For example, radio teletype interfaces, radio facsimile receivers, so that you could actually hook up a radio to your Microbee via the kit. It will decode those signals and either display the text information for radio teletype, or you could print out weather maps and so on.
We were talking earlier about that because the one that we've got here at the museum has had a coating, a spray coating, to try and reduce the RF noise that come from the machine, which was common in loads of machines at that time.
Yes.
But you said about that you couldn't actually necessarily take the radio and play it live into it. You had to record it first.
Yes.
So
unless you had a very, very strong RF signal coming from the transmitter you were listening to, like most machines at the time, they were very noisy electronically. It was best to actually record the signal that you wanted to decode onto a cassette tape.
with the computer off.
With the computer off, yes. And then play it back later on once you've recorded the full signal and you don't have any interference going on. Yes.
Again, another thing, that's very much of the time. Not to be able to do it live, but you have to record it first.
Yes.
Yep. So did anybody create third-party upgrades and things for it?
There were a number of companies that did external PCBs that you could add on to it. There was a 50-way expansion slot in the back on the core board, which is the memory board. So you could actually plug things on there, and that had the full Z80 bus essentially coming out.
Yeah.
So there was a number of different kits and products available to plug onto that interface, and one of them was like a multi-prom interface, so you had a whole bank of different EPROMs for software that you wanted to run at various stages, and you could just issue port commands to it to tell it to switch to
banks in. Yeah,
different.
Because it'd be too much for the memory map in one go to have all those ROMs there, so you just switch them in by bank.
Yes,
clever.
That's right.
Right.
Yeah. So there was a number of different products around from other companies. They not particularly big sellers, but there was certainly a market around for people to develop their own hardware and sell it for the Microbee.
Because that's an interesting thing about the time in general, and I know I make these comparisons with the BBC, which is probably annoying everyone, but actually for the BBC there were a huge number of companies making third-party items for it, because the machine itself was quite expensive over here. That was $399 as well in the UK, but that was a lot of money. It might be the governments and schools could afford it, but for a lot of home people it was just too much money. And therefore a lot of peripherals and things were quite expensive too, but all these companies were kind of born out of making peripherals for these other machines, which is quite nice, because for that kind of time it was a relatively small industry. One person could feasibly develop a product that would go on it, and it created a whole industry based around it, of all these support companies.
Well, we actually had a couple of products that were originally designed by someone else, the Beethoven and Beetalker peripherals that you could plug onto the parallel port. The Beetalker, a voice synthesizer, and Beethoven was a sound generator, so a 3-voice sound generator because of the poor sound the Microbee already had. They were designed by another company, and they started manufacturing those themselves. Then, as Microbee, the company, saw a need for those products, they said, well, you know, we'll buy the designs from you and start manufacturing it ourselves. And so we had an extra couple of products that, you know, someone else had designed.
Yeah, fantastic. What was the sound chip in the sound one? Do you remember?
It was the AY38910.
Right.
Yes.
Okay.
I've actually redone those as a kit that you can build and add on to your Microbee. They're available on the website, and you can actually, I've put extra headers on them so you can program them from an Arduino if you want to as well. They don't have to go on a Microbee.
Oh, nice. Okay, cool. Well, that takes on quite nicely to where I was going to go to next with the latest version of the Microbee. So a few years ago you relaunched it as a kit again. I believe we've got one down there that the museums got at the time. Much more beautiful looking in terms of it's not something as yellowed as the old one.
Yes.
But this is very similar to the original, but also substantially upgraded.
Yes.
Can you tell us about that?
So what happened is that I worked for the original company, and because of the influx of IBM clones around 92, the company just shut its doors.
Right.
Everything was put away in storage, thankfully, by the owners at the time, and I relaunched the company back in 2012 with this new kit.
Right.
It seemed to me, because we had 120 of these case sets in stock, it was a good way to test the market for acceptance of a kit computer again. And so I went about designing this machine. The case sets were there, but they also had their original PCBs in them. Right. With this kit, the original PCB for the baseboard, the one with the CPU, the screen controller, the I/O controller, the keyboard, and you know, it's glue logic and all that sort of stuff, is there. But then I redesigned the top board, which normally housed, in this particular model, the disk controller, the DRAM, and the boot ROM. So I replaced that with a new design, which was all surface mount. It was pre-assembled to go with the kit, so that really, as I call it a hybrid kit, essentially, because the baseboard with the keyboard and the CPU and everything, that was the bit that had to be assembled by the person that bought the kit.
That's all original?
Yes. And then the new board added some extra functionality, some more memory, a second processor, so that you could run UC Linux on it as well.
Right.
But it also has an SD card on it which handles the floppy disk emulation.
Right.
So
Okay.
it looks to the original software like it's still running on an old disk-based Microbee.
Right.
But it's SD card for the file storage.
So it's much quicker and just much more convenient
Yes.
to get the software onto it. Fantastic.
Yes.
Can we take a look at that kind of
Sure.
handiwork?
Yep. So that's with the top case off.
Right.
This is the board that I designed to replace the original memory board.
So that looks much more modern.
Yes.
So you got some fairly heavy duty surface mount chips on there.
Yes.
So
there's a couple of main chips on here that I'll point out. This is a cold fire processor.
Right.
It's a derivative long down the track of the old 68,000 that's used in the Mac and so on. So there's that chip there which handles part of the SD card emulation. The floppy disk emulation on the SD card. There's some glue logic in this chip here. It's a small gate array,
Right.
basically, which handles the transactions between the cold fire processor and the bottom
main
board.
Right.
Okay, because the cold fire can actually run, when it's running UC Linux, it needs to make use of all the baseboard as well for the keyboard interface and the screen memory, that sort of thing. So that's all the glue logic in there. 2 megabytes of RAM. One's sort of dedicated to the original Z80 based operation.
Right.
So your CPM and all the software that ran on your original Microbees ran in that first megabyte of memory. The machines actually came out originally with 128K of RAM in their disk configuration, and that was bank switched as well. Being Z80, it could only handle 64K of space. Additionally to that, there was an option to fit an actual disk controller.
Right.
So you could plug on a 34-way cable out to a floppy drive if you had some floppy disks for an old machine that you
right. Yeah.
had.
Oh, so this is great for archiving the old discs that were out there.
Yes.
Fantastic.
Yes, that's right.
Just dump them across to an image on the SD card.
Yes, exactly.
Fantastic.
And on this one, I also included Ethernet, higher speed serial port, because you could.
Just because you could. Fine.
Yes.
Yeah.
Yep.
Whatever.
So,
Fantastic. So it lives again. And what's the reception been like?
well, the 120 sets sold out very quickly.
Right.
I'm working on a new version of this, a cut down version without the UC Linux end of things, so that because at $399, which was the original kit's price, I did this one for $399 as well. People were saying, "Oh, it's a lot of money to spend on a kit computer that's a Z80 running at 3.375 megahertz when I can go out and buy a laptop for almost that."
Missing the point, though, really, isn't it?
Yes, exactly.
You get to build this one. You get to completely understand how the thing works.
Yes, that's right. It's the ability to put it all together yourself and fault find if you need to, or and then go about learning the hardware and being able to program it yourself. It's an experience more than just buying an item.
No, absolutely. Yeah, it appeals to a certain kind of person, people.
Yes.
Needless to say, we bought one.
Yep.
So yeah, no, absolutely, that misses the point. So in the UK, it sounds very, very similar, but we had this heyday of 80s into the early 90s computing, and then IBM and Apple came along and ruined all that for us. But then there was this more of a resurgence recently, based around things like the Raspberry Pi, which was probably a big driving force of it in the UK. But for people to get back to grips with the hardware, to get to understand what a computer really is.
Yes.
It was the resurgence of the Microbee for the same reasons in Australia, or is there any kind of resurgence in Australia for that kind of thing?
Well, one of the reasons I brought out that kit was at the time that I started looking at all this, there was nothing around Arduino hadn't really taken hold, Raspberry Pi wasn't around. There was nothing, all of the kit suppliers in Australia from the electronics hardware stores were starting to lose interest in that even. We had Dick Smith Electronics, which was a major player in the 70s, 80s, for all of the hobby kits and that sort of thing, had been sold off and was no longer doing electronics.
No.
And it was a very disappointing time, and it appeared to me that a lot of kids were growing up just having all this technology thrust in front of them, being entertained by it, but having no real interest or way of exploring how the actual electronics works. To go and try and understand what's in a modern PC takes a lot of time to understand the actual electronics in it, and maybe a uni degree even. So we needed to go back again to some simple building blocks, and that's what the Microbee is in that case, where it's just a separate CPU, a separate bit of RAM and ROM and a screen controller thrown in and things like that. So it brought it back to physically identifiable parts to aid in that education of people that wanted to tinker in, getting an actual computer going for themselves.
Fantastic.
So that was the idea behind it all, to try and encourage that sort of desire for knowledge.
Yeah, kind of hacker mentality, just find out how it all works and make it do the things you want it to do. Because that's what drove this whole industry in the first place anyway. People coming up with their own ideas for the way they think things should be done. Some of them were great, some of them terrible, but it didn't matter. It was all the creativity that counted.
Yes.
And it is a bit of a shame that that was lost sort of in that period. So you had 120 of the cases.
Yes.
They've gone.
Yes, they have.
So now what?
Now what? Well, I've got a number of different models in the pipeline, and the Classic Plus is the next one along, which essentially is the same as the Premium Plus, without the case, just selling it as something you'll build, learn to program, and just have on a desk somewhere with rubber feet. It keeps the cost down a little bit. Cost was a little bit of a factor in the whole thing.
Injection moulded plastic case. That's big money just to tool it up, and so it's very difficult.
It is. But then I've got later models coming along, which I've got a different set of cases for that are in stock, and we're designing bits and pieces to go in that as well. So there's a number of different models coming.
Right. So those cases back from the days of the original production run?
Yes.
Right, okay.
Yes, we had a machine called the 256 TC, although the case was actually designed for a machine that never came out.
Oh, right.
The 256 TC and the Teleterm, and later on a machine that was named the Matilda.
Right.
It was actually, that machine was a last-ditch attempt by Microbee to claw back some of the education business.
Right.
Once the IBM clones had started flooding the market, it was an IBM compatible, but it also had hardware in it that you could run your old Microbee software on it.
Right.
So the Matilda was, I think they did a production run of 200. Before they just shut the company down altogether. But anyway, as a result, I've got 1,200 cases in stock, ready to go in a new model. So,
So exciting things come from then.
Yes.
Fantastic. Well, thank you very much for firstly coming over and seeing us. Not exactly a short journey, so we really appreciate that. And helping us with our Microbees. You very kindly sort of helped us out in the first place, getting one. We had one in the kit, in the collection already, original. But we like to have these things out and working. So you sort of helped us out with the modern version. So thank you very much indeed for that. Really appreciate it.